Good morning, students. In previous period, we have seen lens maker's formula. The lens maker's formula, with the help of this lens maker formula, we'll solve some examples. First example, both the surfaces of the convex lens have a radius of curvature of 0.05 meter and the refractive index of the glass is 1.5. Calculate the focal length of the lens. Solution. The radius of curvature of the surface upon which the light rays are incident, R1, is positive because the direction from the surface towards the center of the curvature is the same as the direction of the incident light rays. The radius of curvature of the other surface is negative because direction from the surface to the center of the curvature is opposite to the direction of the incident light rays. Now, here in this problem, the given data is n equals to 1.5, R1 is 0.05 meter, R2 is equals to minus 0.05 meter, and we want to calculate the focal length. By lens maker's formula, the focal length, with the help of lens maker's formula, we have the lens maker formula as 1 upon f equals to 1 minus n into 1 upon r1 minus 1 upon r2. Keeping the values in this formula, we get that we put that values in this equation. That is 1 upon f equals to 1 minus 1.5 minus 1, where 1.5 is the value of n, into 1 upon 0.05 minus 1 upon 0.05 into m raised to minus 1. Therefore, putting these values and doing the calculations, lastly we get 1 upon f equals to 1 upon 0.05 meters. Therefore, f equals to 0.05 meter. Here, using this formula, we have calculated the value of f. Now, we'll see the second example. The second example is of this type. Both the surfaces of the concave lens have a radius of curvature of 0.05 meter. The refractive index of the glass is 1.5. Calculate the focal length of the lens. This formula or this example is similar to the first example. Here in this example also we have to calculate the focal length of the lens. The radius of the curvature of the surface upon which the light rays are incident, R1, is negative because the direction from the surface towards its center of the curvature is opposite to the direction of the incident light rays. The radius of curvature of the other surface is positive because the direction from the surface to its center of curvature is the same as the direction of the. The given data is n equals to 1.5, R1 equals to minus 0.04 m, R2 is equal to 0.05 m, and we have to calculate the value of f. Now, by lens maker's formula, we have 1 upon f equals to 1 minus n into 1 upon r1 minus 1 upon r2. Keeping the or putting the values of n, r1 and r2 in lens maker's formula and solving it, we get 1 upon f equals to 1.5 minus 1 into 1 upon minus 0.04 minus 1 upon 0.04 into m raised to minus 1. Doing the mathematical calculations, we'll get 1 upon f equals to minus 1 upon 0.04 m raised to minus 1. Therefore, f equals to minus 0.04. In this way, we have seen this, we have solved these two examples which is related on the lens maker's formula.